So in this section, we are going to start with Bluetooth and we will see what is Bluetooth. So before starting to find vulnerabilities in Bluetooth protocol, let's just first study a bit about what is Bluetooth protocol is and how this protocol works. So the reason behind studying a protocol is uh, 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 if we directly jump into finding vulnerabilities, we will end up only finding the vulnerabilities which currently exist in this protocol, right? And if we study the protocol, we might be able to find vulnerabilities near future as well because we understand the protocol. We also did the similar method in our Wi-Fi penetration testing course as well, if you have done that course as well. So we first study the protocol, how Wi-Fi protocol works, and then we find the vulnerabilities in that protocol. So similarly, we will start with Bluetooth, and first we will try to study this protocol and how this protocol works so that we understand this protocol, and then we will try to find vulnerabilities in this protocol. So let's just start with what is Bluetooth. So Bluetooth is a short range wireless communication standard that uses radio waves in 2.4 gigahertz band. Similarly, like Wi-Fi. So Wi-Fi also uses 2.4 gigahertz band to transfer information between devices, and it relies on a frequency hopping spectrum method, which means it rapidly switch among 79 channels. Each channel is of 1 megahertz wide band to minimize interference and improve reliability. So in simple terms, Bluetooth enables two or more devices to exchange data wirelessly without any physical cables. So it uses nowadays in IoT, file transfer, and all these things. We usually use Bluetooth. So when Bluetooth was first introduced, it exists as a single standard. There were no BLE or Bluetooth Classic. The term Bluetooth Classic and Bluetooth Low Energy, which is BLE, were later introduced to differentiate between traditional Bluetooth, which is now Bluetooth Classic, and its low power version designed for modern communication for modern devices, which is BLE. So what is Bluetooth Low Energy? So Bluetooth Low Energy, often referred to as BLE, or we also call it Bluetooth Smart, was created to support energy efficient communication, basically for small battery power devices. While it operates in the same band, which is 2.4 gigahertz band, but Bluetooth Classic uses a simplified protocol, and it reduces the set of channels to 40. This design lowers both power consumption and cost, making BLE ideal for IoT devices, health devices, and these type of applications. So let's just make a technical comparison between Bluetooth Classic and BLE. So as I said, there are 79 channels in Bluetooth Classic, and in BLE there are 40 channels. But if you notice, we uses 1 megahertz band in Bluetooth Classic, and in BLE we uses 2 megahertz band. Power consumption is high in Bluetooth Classic because there is a continuous connection. And in Bluetooth Low Energy, power consumption is very low because there is a connection on demand. So suppose that sensor wants to send data, it will make a connection and it will send data, and again it will come in hibernate mode. So of course data rate will be higher in Bluetooth Classic because there is a continuous connection. So it's good for audio listening, file transfer, and all these data transfer and all these things. Bluetooth Classic is very good. And in Bluetooth Low Energy, we have low rate data transfer. Because there is not a continuous connection, and if the sensor wants to send data, it will send data, and again it will become idle. So that's why the data rate is very low. So nowadays both protocols comes in devices. So if you see any phone or other devices, it supports both protocols, Bluetooth Classic and BLE. So both the devices can work easily, but the graph of BLE is increasing day by day. So we will try to find vulnerabilities in both protocols, Bluetooth Classic as well as in BLE. So we will start working on Bluetooth Classic and BLE from next section. First, we will study the scanning, how we can find devices, and then we will continue from there. Thank you.